Hello everyone, it's Andy here from AM Media Games, and in this video I'm going to be showing you how to create a laser tripwire. So without further ado, let me jump in and I'll get right to it. So the first thing we're going to do is try not to cough. I failed that mission. So the first thing I'm going to do is create a blueprint actor. So you can see here I've got a blank level, and in the blank level we're going to add some kind of a door frame. So let's go to modeling tools. So at the top here you can use the shortcut key Shift 5. We're going to go to modeling tools. Once we open that, we're going to add a box, and we're going to get snapping on, set that to maybe like 50, and then you can snap it to the 1 meter square on the grid. So I'll snap that one there. We'll bring the depth in a little bit, click accept, and then we'll make a door frame. Let's just check the size, so we'll click play here. Yeah, probably about right. So let's copy these, hold Alt and drag, and then Alt and drag again, select one, Alt drag. So now we have a door frame. In our door frame we want some kind of a laser kind of tripwire that's going to go off when we walk through. Just need to make this a little bit wider, so let me change the spacing to 10. Do the same for this one. Let's bring that up a little bit. Actually, do you know what I'll do? So I'll delete that and that one. Let's delete all of these. Yeah, and use the cube grid. Actually, no, we'll use no. We'll use the box. It's fine. It's fine, Andy. Just use the bloody box. Right. Okay. So we'll place that. We'll set the height about maybe there. Click accept, and then we'll copy it and bring it over, and then we'll do another box, and then we'll drag the height down, bring that up, bring the height down a bit more. Okay, it's a weird looking door, but it doesn't really matter too much. Okay, so this is, my OCD's kicking in now. Right, stop this. Dangerous to yourself. Okay. Click accept. Bring that down a little bit. Can I fit through it this time? Perfect. Right. So we have a door frame, and we want to place. So you can imagine like a James Bond film or some kind of like special forces TV series, and they're like, oh, there's a tripwire we can't go through, but we're going to make a laser version. So what we're going to do is I'm going to go into this folder here. Now I've already got the laser particle effect created and a material. I will go over those near the end of the video, so stay tuned for that. I'm going to right click. I'm going to cough first, so apologies, 1 second. Okay, so now that I'm over that cough, let's move on with the video. So we're going to right click, go to blueprint class. I'm going to go to actor. I'm going to name this one to laser trip. My brain's not braining. There we go, tripwire. And I'm going to open that up. In here, we need to add a few things, but we're going to start with the code. So the first thing we're going to do is go to event graph. I'm going to delete these two because we don't need them. Once we've deleted those, what we can do then is create a custom event. Once we've created the custom events, we're going to go right click, custom events, add a custom event. I'm going to name this one laser trip wire loop event, because this is going to be ticking over and over to try and detect the player when it walks through. On a side note as well, if anybody wants any free models, I do have a Sketchfab account where I upload all the models for free. They vary in requested models to custom models that I've uploaded for people to use for free, the sci-fi kind of mainstream models to use, horror theme based kind of models. But if anybody's got any requests and you're a subscriber on YouTube, feel free to jump on Discord and send me a message, and I'll look into making some free low poly models for your horror games. So just as a side note, but anyway, let's move on. So we've got event begin play and we want to utilize this because when we start the game we want the tripwire to be active. Now if you don't want the tripwire to be active, then you would skip this and you would have it on a switch or an event. So a specific event would trigger this. If it goes quiet for a second, it's just me muting the microphone. So we're going out of this one now. We're going to get a set timer by event. Now this is a really good node instead of using an event tick. An event tick isn't a bad thing, but it is when you start using it too many times, and it puts a lot of resources on the CPU, especially if you've got a lot of code running off it. So this is kind of like an event tick in a sense, but the difference between an event tick and this one is an event tick. Let's get the event tick. This will fire code however many frames you have. So every second, if you're running at 240 frames per second, then you're going to be firing code off 240 times every second. So it's not too bad to use it for things like screen overlays for interactable objects, but it's not a good idea to use for things that are going to be firing off of a code like alarms, or maybe like I don't know, like detecting if a player walks over a laser, for example, that's going to trigger an alarm or a turret or a door to open. So let's delete that. So in here you can see I've gone over this node a few times in other videos, but I don't mind going over it again in this one. So the important thing is that you have your delegate pin. So this is your output pin. The code, imagine this is like a highway or a road. The code always moves in this direction and it will travel from this node to this one. And when we simulate, it will fire off and you'll see an orange path going across. This delegate pin connects this event to this. So this is basically saying, oh, we want to loop this event track. So we're going to create a looped event. We're going to set a timer of maybe like 0.1, and we also want to set this to looping. So out of this we're going to get a line trace for objects, and we want to make sure we pick line trace, not multi-line. So line trace for objects, but we want to create a point where it's firing that detection from. So we need an object to reference in our code for where we want the line trace to start. So in order to do that, we're going to add in, just for the tutorial, you'd have to swap this out for something else. We're going to add in an arrow, and the arrow, we're going to get a get world location. Oops. Get world location. So this node here, this is going to get the world location of this object. Then we want to get forward vector. This node is going to get the forward direction of this object and give us a translation in a world space and giving us an actual vector range to work with. And we want to plus, so we're going to get right click plus and oops, wrong one. We'll get it out of this plus. There we go. And we want to swap these round, so that goes in there. No, that doesn't go in there. We want to multiply as well, so let's get a multiply. that goes in there. This goes in here. This goes in here, and this goes in here. So arrow, get world location, return value to start. Arrow, get forward vector, return value to A on the multiply. The output goes into the B channel on the plus, your addition node. The output of the addition node goes into the end. The output of the get world location also goes into the A channel of your addition node. Okay, we're going to right click, convert to float single precision, and then we're going to give it a distance. So this is going to be how far forwards the line is drawn from the object. The object is the arrow. The arrow is this red line, or this red arrow. So 300. Draw debug type persistent. Compile it, and we can see we have an error. To fix that, we need to come out of object types, and we'll go array, make array, and then we're going to get pawn, because it's going to be our player. Excuse me, let's have a quick drink. Okay, so what we want to do is we're going to get a branch, hold B and left click. So B for branch and left click, and you'll get a branch node. The return value is going to go into condition, and the output is going to go into the input on the branch. Out of the out hit, we're going to get a break hit result. So drag out and drop, and then right here you'll have break hit result. If this is unchecked for any reason, you won't see it. So check that on, make sure it's context sensitive, and then have out hit, break hit result. You're going to click the little context menu, little drop down hidden box, and we want hit actor. Hit actor is going to have actor has tag, just like so. I'm going to give that a tag of player and press enter. Once we've done that, what we do is going to get an is valid node. So we're going to drag out of this and get is valid with the question mark, and true goes into the execute, and out of the is valid node we want a branch. So hold B and left click, hold B and left click, is valid goes into branch, condition goes into return value, goes into condition, a second branch. So this is what it should look like so far. Yep. So uncheck ignore self, click compile, we can see we can get rid of that error now that we have our make array. So just like so. Okay, we can click this arrow now, drop that down, tidy this up a little bit. That's it. And a couple of reroute nodes. If you double click the line, you can get a reroute. Okay, so that's that done. And the end part, what we want to do out of branch is we're going to get a play sound. This is going to give us an audio indicator to tell us it's working. So we're going to get a play sound at location. The location is going to be the location here. So we can drag out of this, get world location, pop that into there, double click, bring that above, double click, bring that above here, just like so. There we go. And then in here we need some kind of a beep, so let's see if we can find something. I mean, that'll do. Okay. We're going to add a little bit extra later on, but that should all be working fine. Now to start this loop, we need to add some code in here. So we need to get this custom event, grab its function, which is just here, this graph. So we're going to grab that, drop that there, and then compile it, go into the level, take our laser tripwire, bring that up, press G so we can see the arrow rotate 90 degrees, bring that in, and there we have our laser. If we click play, we see our laser is going through, and when we walk over it, it'll set off a trigger, a sound, or an audio. Now that won't work first time for you, because what you have to do is press Control Spacebar, go to content, go to your first person or third person character, open that up, click on the very top, go to the search bar, type TAG, go down to where it says index, tags, advanced actor, so actor tag. Now let's go back to our laser tripwire, and this is where this is important. Actor has tag. Go to your first person character, actor tag, player, make sure it copy. So we're going to copy and then paste. Compile it, go into your game, go over it, and it beeps when you walk through it. So go over it again, and it will go off every time. Now we can prettify this a little bit and make it look a bit better. So let's go into our tripwire, let's go to viewport. We're going to bring the distance down slightly, so let's have a quick look what we've got in here. 300, let's bring that down to maybe 100, compile it, go into the level, test it. Okay, that's much better. So that's going through, but it's not going through like it was before, and then off into the distance. So we have that done. Let's delete this top piece. And if we go in and jump, you can see as long as you don't touch it, we don't have any sound going off. So that's interacting with our player. Now the next step, what we want to do in our laser tripwire, let's add some detail to it. So let's go to viewport, let's go to add, and then we'll go to let's do cylinder. Let's add a cylinder. Let's bring this down, let's shrink this down a little bit. Oops, let's go a little bit slower. Rotate this way, 90 degrees, shrink that down a bit more. Excuse me. Compile it, let's go into the level, and we can see here we have that start of that kind of cylinder for our laser beam. Ignore the arrow, don't worry about that. And then what we're going to do is we're going to add another one. So let's Control C and Control V, create a second cylinder, and let's move this one over. Let's go into our level, see where that is. So we need to go a little bit further. So it's kind of like there, probably be a little bit less. It's not too bad. So we'll turn off snapping, bring it out a little bit, compile, and there we have this kind of like start point and end point for our beam of light. And then what we're going to do is we're going to, let's right click on this, browse to asset. We're going to go and create a Niagara system. So I'm going to right click, Niagara system, new system from selected emitters, and then we have dynamic beam. So go ahead and open that up, click plus, finish, laser underscore 2.0 tutorial. And we're going to open, and in here we're going to change a few settings. So we can see here we have like a weird shape to it. It's kind of like a bullet ripple, right? And we don't want it to look like, we want it to look like a laser beam. It needs to be relatively thin, quite long, and look like a laser. Currently it looks like, yeah. So we're going to go down to particle update, not particle update, particle state, my apologies. and we want to uncheck particle, kill particle when lifetime ends. You can see here when we have a certain amount of time, it fades in, fades out. So we're going to uncheck that, and then it will stay forever. Well, it should have. Let's have a look. It shouldn't be ending its life. Okay, so we have a laser here and we have a particle state, and it's exactly the same. Emitter state set to infinite. Yeah, loop behavior, continue emitter, complete, kill emitter, particles, continue emitter, deactivate but doesn't die. That's the system does. It shouldn't be ending. I love Unreal sometimes. Some things seem to just work perfectly fine, but then when you go and do a tutorial on it, or you go to show somebody, it just kind of goes, nah, we're not doing that today. We're not going to work. Let me open up this one, and we'll go over the settings. So in our ribbon render, we have a laser material. So let's open my laser material. So you're going to right click material. I'm going to call this laser underscore material underscore 2. Open that up. First thing we're going to do is change this to translucent. Then we're going to hold free and left click, my bad. I'm going to select a color. So let's do red. And with this now, what we want to do is we want to connect this up to our base color. We're going to hold M, get a multiply, connect this up into A, hold 1 to get a constant, set this to, let's say, 5, connect that into there, that's going to go into emissive, and then here on opacity, we're going to set a constant as well. So let's do 1 constant, set this to 0.3, and then plug that into there. So we have this kind of laser dot effect. Apply it, save it, and then in here we can apply this material. So click on ribbon renderer, go to the top where it says material. I'm going to click on my material and I'm going to apply it to the laser. You can see here we have this see-through, slightly transparent laser beam. In the particle state, you want to make sure that this is off. Kill particles when lifetime has basically ended. You can see there it's been unchecked, got the undo. Beam width, you're going to set it to 0.9, 0.325. You can see you want your line to look like this. So around somewhere between 0.2 and 0.4, but around 0.3. Spawn beam, nothing. Initialized particle lifetime 3 seconds. And then you've got spawn count, beam emitter setup, and then we have our infinite, complete, let particle finish, and self. Okay, so in our laser tripwire, we're going to go to, let's click on our laser. Let's delete this one. Click on our laser, and then we're going to go to add, and we're going to click on Niagara Particle System Component, and it'll add it automatically in for us because we have it selected here. So you can see here we have our laser beam right there. It's going through. Let's hide the arrow. It's going all the way through and through the wall. So we need to reduce its distance slightly. Let's go into our laser. Go to our emitter. Where is it? We need our beam end. So we're going to set this to 100. Save. And there we have a little laser tripwire beam. If we go, let's drop the lights down a little bit. So scroll up, directional light. Let's do maybe 1. And let's add in a post process volume. Please don't crash Unreal. There we go. In here, we're going to go and search for bound. I'm going to set the extent to infinite. So it's the entire level, not just this small section. All this means is, if this is unchecked, the post-process volume is anything that's inside of this cube. When you check this, it's then global. So it ignores the space within the cube and it's everything everywhere. So this will impact only when the player is inside, and this will impact wherever the player is in the level. So that's what that button does, just in case you didn't know. We're going to scroll down until we find bloom. I'm going to check all lamps on and change it to convolution. You don't have to do this. This is just for looks. And we can increase the intensity to give the beam a nice glow. And the next thing we can do is scroll down to exposure. I'm going to check all these on. I'm going to set this to free, 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 and free. This gives us more control over our lighting. Doesn't give us any kind of strange increase in light. And what we can do then is we could actually drop the lights all the way down, set the mood. So let's drop the lights all the way down to 0. There's our lightsaber, and we're going to add a light in. Let's do a rect light. Let's bring that up. So have this kind of maybe like a corridor and a little laser beam at the bottom. So if we go into the level now, you can see here we have the laser, and if we walk through it, it still sets it off. Right, so how do we now control something in our level? So this is kind of a bonus part. So if this is enough for you, you don't have to continue doing this, but this is just kind of like an extra bit of icing on the cake. So what we're going to do now is we're going to go a bit more of a deep dive into triggering events using the laser tripwire. So now that this is all set up and you know how to set this up, which is super easy, we're going to add a little bit of code at the end here. We're going to go to event dispatchers, and in the event dispatcher we're going to name this one to laser tripped fire event. I'm going to drag and drop and do call. Connect that there, just like so. Okay, so when the player walks over the tripwire, where we can adjust the distance here on this node, when the player walks over it and a sound is played, so this is basically making sure it's valid. So it has been triggered by player and we have the branch. So if it's true, we're going to play a sound, and just here we're going to call laser tripped. Let's fire an event. An event dispatcher is, imagine a really big racetrack, and you have a crew of people with pyrotechnics, fireworks, and they've been told that they can only set those fireworks off when the first car goes over the finish line, but they can't see that car. So the only way they know it happens is if somebody sends them a message So let's say somebody calls them up, yeah? So when this happens, it sends out a message, but we need a receiver. So to create the receiver, we're going to go into our level blueprint. So up here we've got these 3 squares connected by some lines. So our blueprint, basically our blueprint graph. Open our level blueprint. Ignore this. This is just because I've not saved the level. And in here we have event begin play. If you're using this, don't worry about it. It's fine. You can just add it on to the end. There's another way to do it, but I'd end up making a 3.5 hour video, and nobody wants to sit through listening to me for 3.5 hours. So what we're going to do is we're going to add in our laser from our level. So we have our cool little laser beam detection system down here. We're going to click on this. I'm going to go into our level blueprint. Let's move this over here. We're going to right click. I'm going to get a reference. Drag out of this, and we're going to get bind event 2, and we should have bind event to laser tripped fire event. Bear with me 1 second. Right, okay, so out of event begin play, we want to bind this. So all we're doing when we bind an event is basically just making it valid. It's an event that can be triggered. You might have a section of your game or level where you don't want a specific event to be able to fire when you walk over that tripwire, but on the way back you do. So to do that, you can create a custom event, and we can call this bind events. This is going to bind this event. You don't need to connect these. It's not what that's there for. This is for something different. I'll show you that in a second. Then in event begin play, you can create your custom event, bind events, you get the function of it in the event graphs, and then you can drop that there. So you don't have to have the code all the way up here and then big lines going everywhere. You can just do it like this. So this event begin play will call this event, and this will bind this event. So there's other ways to do it. This one is what you want to happen when this gets triggered. This is just binding it. This is making this valid. So this is like the pyrotechnic dudes waiting for that call. So this is now valid. They're waiting. They have the phone. They're ready. They just need a signal. We're going to create another custom event, and with this custom event we're going to name this to let's say open, or actually close, initiate lockdown procedure. Let's do that. This video is going to be a bit longer than intended, but it's all good. Please join me for the ride, and if you like the video, please hit that like button. It really massively helps me out with the YouTube algorithm. Consider watching the video as well without ad blockers on, because it's one of the only ways I can make an income through YouTube with ad revenue. So I appreciate you, and subscribe as well. If you enjoy the content and it's helping you learn, consider hitting the subscribe button. It's free. So thanks very much anyway for watching so far. So this one here needs to connect into the event. This is bound when we start the level, and this will get called when it's triggered here. So when this gets triggered, the call, where are we going? There. This is the event that we're going to play. So I am trying so hard not to cough. Let's have a quick drink. Okay, so, right, what we're doing. What we're doing is, we're going to create an event. So, let's go into our level. Let's put it in unlit mode just so we can see what we're doing. We're going to create a quick corridor. Let's put my teeth back in. Create a quick corridor. Say that 15 times really fast. Okay, so I'm going to go with a box. We're going to put on snap to grid, set it to 50. Put all settings to default, and that'll do. So we'll do one there, one there, one there, one there. So all I'm doing here is Alt and dragging, and that will create a new instance of the object, just like so. And there's our corridor, and then we need some kind of a place to do this initiate lockdown thing. So let's do all of these ones. This is not how you design a level, so please do not copy this. This is far too many meshes just for a corridor. This is only for the tutorial, so anybody comment going, that's not how you do corridor, well, it's a tutorial and you can do it however the bloody hell you want in the tutorial. It's fine, as long as people understand what's going on. So we have a corridor, and we have a panel here, and what we're going to do is, let's go back into lit mode and see what this looks like. Let's drag that down a little bit and let's rotate it 90 degrees. Let's bring that up, turn off snapping, bring it down and across. Okay, so we have a corridor and we have a couple of doors, very interesting looking doors, and we want this one to be like maybe we do some kind of like, yeah, like a shutter, like an emergency. So put on snapping, pop that in between these two, bring that depth down slightly, and we'll bring that height up as well. Let's do snapping off, click accept, stretch it a little bit. Okay, so all the way up we go. And yeah, that'll do. Okay, it's a bit on the thinner side, and pop that there. So this will close. Excuse me. Okay, so now we have a door and we have our laser. We want to trigger this to shut only when the player accidentally walks through or trips this laser detection. So what we're going to do is, if we go into our level, we can see here we have the laser, we have the doorway on the other side, and we can trigger that when we walk through, but we can still go through this door. So I'm going to do a quick animation in our level sequence, and we're going to do that by going up here and then add level sequence, lockdown door system anim. I'm going to click save, and then in here we're going to add that door, so we're going to click on it, make sure it's highlighted, go to track, add to sequence, and then add box. With the box selected, I know the video is getting long, but some people might want to know how to do this. So if you've already learned enough and you're good to go, that's perfectly fine. But I apologize for the length of the video. If you want to watch it all the way to the end, amazing. If you don't, That's your choice. That's not a problem at all. Everyone's entitled to their own opinions and choices. Free will. Okay, so we've got that added in, and we're going to go to transform. We're going to get rid of scale and rotation, and we only want to move it on the z-axis. We can see here when we move the slider, we've got the door going up, we've got the door going down. So we're going to get rid of y. Don't ask why. Get rid of x and y, and just keep z. Now that we've got the z-axis, let's move the microphone, sorry. Now we've got the z-axis, we want to add in a value for our start location. So we click plus, that'll add a keyframe. So this is keyframe animations. The keyframe will hold the z-axis location data in its little value, in that little dot. So right there in that little tiny dot is the information here saved in that spot. So when we go to this point, it knows that that's the world location based off this in that little dot there. So we're going to move this to, let's say, 2 seconds. I'm going to get our end timeline point, move that to just after the 2, and then from here we're going to move it into the position we want. That's going to be like so, and then it will automatically update. So when we move this back and forth, you can see here that we have a simple door animation. So there's our lockdown procedure. The shutter goes down, the player's like, oh shoot, I'm trapped. We're gonna right click on the green bar, go up to properties, scroll down, click and keep state. It's very important that you use keep state when using level sequences and movement. If you don't, it can cause problems when you go to reverse the sequence, especially if you're trying to use the same object and you want to add another level sequence to it to make it move somewhere else. If you don't keep state, what that means, so when it moves from position A to position B, it will then update its world location, so it keeps the current state at the end frame. If you don't use keep state, it will think that the door is still in this position, even though it's in this position at the last frame. It won't keep the state or the current position at the end frame of the animation. So we'll right click, keep state, and you can see here when we move in the top right of our blue, which is our z-axis, we have the updated values. So that will keep those values at the end of the animation. The next important thing to do is press G so we can see everything, and we need to find this little thing, and then we're going to go down to pause at end. So that will stop it from going back. If we don't do that, it will replay the animation. Okay, so nothing's going to happen when we go in. So we can go into the level, we have our door, it gets triggered, nothing happens. So we need to set that up. So go into our level blueprint, make sure we have our, where's it gone? There he is. We're going to click on this, right click, create a reference, and with our reference selected, we can drag out and click play sequence player. It's that simple. So this is going to play that sequence just like this, but we also want it to reverse, right? Because we also want the door to open when the player walks away, because we need a way to reset it. Now you could do this off a switch, like a reset system. This could be a computer that you interact with, it could be a switch on a wall, it could be on a timer system. anything that you want to do, you can do. The only limit is your imagination, literally. Okay, so what we're going to do is we're going to connect that in, but we want to do it once. So hold O for Oscar and left click, and we're going to do a do once. Completed goes into play, just like so. So this is going to trigger this when we go through the laser. So let's go over here, play, and let me just quickly come out, save that and close. Okay, now play. So what should happen, hopefully, what should happen is when I walk through this, it should trigger that alarm and the door closes. Yeah? So we can see that happens. When we go back through it, it doesn't reset. Now that door is on lockdown. We cannot get through that door. If we go over to that door and we try and walk through it, you can see we're blocked. We can't walk through. Works perfectly, exactly the intended purpose. The only problem is now we can't open it. So how would we open the door? I'm glad you asked. So let's go into the level. Let's go into unlit mode. And let's extend our really amazing corridor out a little bit more. And we'll do snap to grid. We'll move this out. And we're going to have to get a little bit more technical now, because we're going to add some more code in, so we need things in to stop it from breaking. So we're going to add in a trigger. So this is called a trigger. And we have a few variants. We have trigger volumes, trigger spheres, capsules, and box. I'm going to add a box trigger in. Press G so we can see it. Move it up. Press R. Extend it out so it covers the full corridor. And just pop it here at the back. So with triggers, the important thing is make sure the player can't bypass it. So if you've got a trigger in your level that's activated a cutscene, you don't want the trigger to be really small where the player might accidentally jump over it, right? So make sure it's a relatively decent size so the player will always walk through the object. So the next thing we want to do is go into our level blueprint. If you don't remember where that is, it's here and then level blueprint. We're going to right click. We're going to create a reference to our, oh no, we're not going to do that, sorry. We're going to right click and go to add event collision, and then we want let's say begin overlap. So what this is going to do is detect the player. So we can also do actor has tag if we wanted to, and we could do paste, oops, we don't want to paste player, and that could go into a branch, and that can go in there, and this will stop everything else and its friend activating your code. So as long as the actor that walks through it has the tag, this will then only allow it to trigger. So we can do that. We can also do a second one, and this one is going to be a variable. So we're going to add a variable, and this is going to be is in lockdown mode, and then that's going to go in there, and we're going to set here to true, and out of true going to go in there. Then we're going to get a reference to this, so we're going to Control C, Control V, oops, not twice, and then out of this we're going to go reverse. So we're going to play it backwards, so it'll open the door for us. Is in lockdown mode, true, play in reverse. Out of here, set it to false. Okay, now that that's done, we can do a, let's do a do once. Let's go O for Oscar and left click. Let's do a do once. And then the reset for this would be this. and the reset for this would be here. I'll explain it, so don't panic. Okay, so a do once node only allows code to fire once, hence the name do once. So when this fires, it can't be recalled, but when we've opened the door and reset this now to false, it's no longer in lockdown mode, it'll then click up here on reset, it'll allow us to recall that event. So if we compile that and go into the level, this shouldn't do anything because it's not in lockdown mode. If we jump over this, nothing will happen because we didn't trigger it. If we go over it, it will go into lockdown mode. If we go all the way back, we can reset that system. And now if we go back through, we can repeat it. So if we go forwards, we reset it. We go backwards, we can reset it. Yeah. I hope you clued in there, and I hope you've been watching and following along. It's pretty much over now, the tutorial. There's not much more that I want to add at this point because it's quite a long video, but feel free to subscribe. If you are subscribed to my channel, I always offer people help on Discord. I've helped hundreds of people so far, answering questions, working on people's games with them. I'm only one person, so keep it respectful. Remember that I can only help so many people a day. I'm only human. I've only got 2 hands. So I hope this video helped. I hope you enjoyed it. If there's any questions, leave them in the comments section. If you do subscribe, remember you can join me over on Discord, and I'll be willing to help you one-to-one or help people learn. But remember, just be respectful because I'm only one man. But yeah, take care guys. Thanks very much for watching, and I'll see you all in the next one. Bye bye for now.